Parts of my videos are still being sped up, so if somewhere in the video I start talking in a fast, high-pitched voice, and usually what happens is my pen will start teleporting around, just appearing and disappearing all over the place. If that happens, you can adjust playback speed. It'll make my voice slower, but the pen will still teleport, which is annoying. So this video is on dilutional problems. I'm going to solve a dilutional problem two different ways. The first way will be with the formula that's quick and easy, and so most of the video will be me solving this problem without the formula. Formulas are great if they're quick and easy, but if you ever forget them or forget how to use them, it's good to be able to solve these problems with just logic. So first way is with the formula. Volume 1 times concentration 1 equals volume 2 times concentration 2. If you look at the units, the volume will have mils or milliliters. The concentration will have milligrams per milliliter. When you multiply these together, the milliliters will cancel out. You just end up with milligrams on each side. Let's say we need a solution that's 10 milliliters of 2 mgs per mil. How much do we need to draw up? We have a concentration of a solution in the storage room, and this is 10 mgs per mil. Just solve for V1, you'll get 2 milliliters. Here's where it gets a little bit tricky. This 2 milliliters actually means you'll have the correct number of milligrams, because when you multiply this volume times concentration, the mils will cancel. You're left with 20 milligrams. So if this formula tells you to drop 2 milliliters, in that 2 milliliters, you will have your 20 milligrams. So now we have the correct number of milligrams of 20, but it's only in 2 mLs and not 10 mLs. So 2 mLs plus a volume gives you the 10 mLs. That means you add 8 mLs. The reason partly I want to do this problem without the formula is because I tended to mess this up, and I wanted to put a volume over here. And anyways, you have to know how to use this formula. You have to know what it means. You have to know that this milliliters gives you the correct milligrams. So like I said, it's just good to be able to solve this logic puzzle with just logic and not with a formula. So that's the easy way. Now this is going to be a fairly long, complicated video of solving it the hard, long way with just steps of logic. Stay tuned if you're interested. In this case, I need this right here, 10 mils of 2 mgs per mil as the concentration. So this is what I need. This is what I have. First step, find out how many milligrams you need, or moles if you're in a chemistry class. So once we find out how many milligrams we need, we use that information to find out how much we need to draw up from what we have in storage. And say in storage we'll have a concentration of 10 mgs per mil, and it'll just be a very large vat, a huge quantity, so it doesn't matter how much we have in storage, we just need a small amount. So in this case, we only need some of the supply. We're not diluting out the whole supply we have in storage. So this is what we need. First step, find out how many milligrams you need. That's our volume, that's our concentration. Milliliters will cancel. 10 times 2 is 20. That means we need 20 milligrams. We need 20 milligrams in 10 milliliters of water. You could say 20 per 10. Draw a box around that and star it because that's important. I'll use this in a couple of minutes. Just to review, we got our 20 milligrams right here from this because we multiplied those together. We get our 10 milliliters right here because that was the initial volume with which we started. I need 10 milliliters of this concentration, so I need 20 milligrams in 10 milliliters. Don't reduce this fraction. That's part of this logic exercise I'm doing here, is just learning the logic of all this. Leave this as 20 per 10. Don't reduce this to 2 milligrams per milliliter. Now that we know we need 20 milligrams in 10 mLs, Let's just use the 20 milligrams because that's what we need to draw up from our storage container. We need 20 milligrams. We have 10 mgs per mil in storage. The mgs will cancel. You're left with 2 milliliters. That's what you need to draw up. So you need to draw up 2 milliliters from your supply tank or supply jug or whatever. Now we'll have our 20 milligrams and it'll be in 2 milliliters right there. 20 milligrams and 2 mils. This is what we have. Draw a box around it and star it, because what I'm going to do is take what I need and compare that to what I have with an equation and just use some basic algebra. These are the numbers that I starred. This is what we need, 20 mgs per 10 mLs. This is what we have. We drew up from storage, 20 mgs per 2 mLs. That's the same as that. So we need to turn this into 10 for these to be identical and for these to be equal. Obviously, you just add 8 milliliters and then you'll have 20 milligrams per 10 mLs, just like over here. If you want to solve for it to make sure, just cross multiply. 20 times 10 is 200. 20 times 2 is 40, plus 20V. Go through the algebra, and volume will equal 8, same as there. I put a minus sign here for the volume, showing that you could theoretically subtract the volume as well. I don't work in a lab, so I don't know how these things are done, but theoretically, if you had a heat-stable chemical, maybe such as salt water, you could put it on a hot plate and cook off a certain volume to concentrate your solution instead of diluting it like I just showed. Just to make this as complicated as possible, let's run it through an IV. Say it's a drug. We have 20 milligrams per 10 milliliters of that drug. We need to give it as 2 milligrams per hour in an IV. We're giving the whole 20 milligrams, and we can only give 2 milligrams per hour. 20 divided by 2 is 10. Or you could set it up with a conversion equation. 20 milligrams at 2 milligrams per hour. The milligrams will cancel. You're left with 10 hours. If you want to set this up as 2 mils per hour instead of 2 milligrams per hour, we're not going to be interested in the milligrams this time. We're just interested in milliliters. We have to give that whole 10 milliliters of the drug, and we're doing it at 2 milliliters per hour. 10 divided by 2 is 5. Or set it up as a conversion equation. Ignore the scribbles. The mils will cancel. That means it'll take 5 hours. Now let's say that our new solution was just delivered, so we want to dilute it out. We want to dilute all of it before we put it into storage. So what was just delivered was 1 liter of our solution, and the concentration is 10 mgs per mil, but that's more concentrated than what we'll ever use. So let's dilute it out to 2 mgs per mil. Use the formula, solve for V2. That means you need to make this 5 liters. So you add 4 liters to this 1 liter and you'll get 5 liters. But because I don't want to have to depend on equations that I could either forget or forget how to use, let's just use some logic. We need 2 mgs per mil. We have 10 mgs per mil. 2 divided by 10 equals 1/5. That means we need this solution at 1/5 of the concentration. That means we need to dilute it out 5 times. So take 1,000, which is what our liter jug is. Put this in a bigger jug that can hold 5 liters. 1,000 times 5 equals 5,000 milliliters, or 5 liters, which is the same answer we got there, solved with either logic or a formula. Maybe I shouldn't have put the 2 on top of the 10 to be 1/5. Maybe I should have put the 10 on top of the 2. So 10 divided by 2 is 5. That means I have 5 times the dilution. I guess it's good to be able to understand how to do this both ways, just for the logic. But now I want to make this even more complicated. What if we don't end up with a simple whole number or a simple integer here? So that's what I got on the next page. We got 5 milligrams per milliliter. In storage, we need to dilute the whole thing to 3 milligrams per milliliter. This time I'll put the 5 on top. 5/3 equals 1 2/3. That equals 1.66, repeating for the dilution factor. So now if we have 1 liter as our original volume, take that 1 liter times the 1.66 repeating, and that tells you how many liters you need total. So we're given 1 liter originally, so we add 666 milliliters to that 1 liter to give us our total new volume. And that's about as complicated as I can make it.